Guys, welcome back to Tronic Synergy, and I know you're all excited to see the automatic light system of this pretty small house, DIY house in action. And I'm also excited, but first I want us to check and understand what the circuit does and how it operates and how the components communicate with each other to produce the automatic light system. It's a pretty easy setup. It's just a simple light detector circuit with the LDR on top of there. You can see on top of the roof there's an LDR there, and there's a white bulb inside to power the house when it detects absence of light. So let's check out the setup and understand what is really happening inside. So let me just explain to you real quick on how the circuit operates. So the first point here, you can see the VCC. I'm using a 5-volt power supply. Then I'm not the switch is not really important. You can put it, or either you can just leave it like that. The first component you can see here is a potmeter. It's a potentiometer or a variable resistor. And in this setup, this setup I drew it for another circuit which this potmeter was a little different from the one I'm using. The one I'm using, actually, the middle pin is the one that's actually connected to the non-inverting input of the comparator. So depending on which potmeter you're using, it depends on how you're going to connect this. But for the one that I'm using, the middle pin is the one that I'm going to be connecting to the non-inverting input of the comparator, and the other pin is connected to ground. The other one is just connected to VCC. So this resistor is not really important. You can just put it, or either you can just leave it or connect it directly to the VCC. The next circuitry is the light dependent resistor circuit. You can see here we have the LDR, the light dependent resistor, which is connected. One of these pin is connected to a voltage divider. It's being tapped from this point. The resistors that I'm using in my circuits are 220 ohms each, 220 ohms each. Then one of the pins connected there. The other pin is connected to the base of a BC547. A BC547 transistor is an NPN transistor, meaning if you can see this setup very nicely, since we have connected it to the base of this transistor, depending on how light, because the LDR, the sensor, works in the principle that the more the light shines on that front part or that top part of the sensor, the more it allows current to flow from one point to the other. So if more light comes, then it's going to allow the electrons to flow easily to the base, and the more the electrons at the base of an NPN transistor, the more it's going to draw more current from the power supply. So that's basically the how the system works. So right here before the collector, we have connected that point to the inverting input of a comparator. So this comparator, there are a lot of comparators out there, but the one I'm using specifically is an LM358. It's a dual comparator, so I'm just using one of the comparators to make or to work in the circuit. Then depending on the pins, you should check the LM358. The VCC is connected to pin number 8. Ground is connected to pin number 4. Then these other pins, the non-inverting input is connected to pin number 3, inverting input pin number 2, and number 1. Pin number 1 is the output. This is the output. Yes, so from the output, this other system does not really matter. From the output, mine simply just lights up an LED. Yeah, that's pretty much what the circuit does. Mine once the output, or once the signals have entered the comparator, it just gives the output. So there's no this circuitry there. So let me just show you the circuit. So as we've said, so this is the IC LM358 that we were talking about. There's a V reference that there. This is the port meter. This one is the 10K port meter. You can see the middle pin. As we have said, the middle pin is the one that we are connecting to the non-inverting at the comparator. Then the inverting is connected from output of the sensor. This is the sensor. This is the sensor input, and okay, it's already removed. Let me just fix it up real quick. And yes, so pretty much that's the whole circuit. That's the whole circuit. And as you can see, it's not really hard. I did this circuit a few months ago, so if you still want to grasp on how these things are working nicely, you can just go or I'll just put I'll put a link below on the video that I did in the light detector for you to understand better. Let me just connect it to the base of the transistor like that. So this as we have said, this is a sensor, and this other one is the LED. So as you can see, the LED, I've connected it to a transistor collector. So this is a transistor collector. So from VCC we have a resistor which is 1 kilo ohm. Then it's connected to the positive of the LED. The negative of the LED is connected to a collector of this transistor. Then the base of this transistor is controlled by the output of the comparator. As we've said, my setup doesn't really look like this. Mine is a little bit modified for a better output. So the reason as to why I've connected it in this manner is because the output signal from the comparator might be low, and tapping that to the LED means that it's going to be turning on the LED, or it's going to be a little dim. The light won't be sufficient enough for the house to illuminate it well. So that small signal, we can amplify it using this. It's also a BC547 NPN transistor, and the function is just to amplify that signal from the sensor or from the comparator in order for it to give efficient light at the house. So having said that, I think we are ready, and I think you have understood how the circuit works well. So we are just going to, let me just move this book so that we can now do the setup and see how it operates. Yes, so let me just power it. We put the power supply. As we have said, we are using a 5-volt power supply, and here you can still use let's say 3, but 3 volts a little bit low. You can, if you're using a 3, maybe you're going to modify the resistors for you to get good output. So the circuit is already powered on, and let's check on how it works. So I'm going to turn off the camera light for it, for me to place my hand on top, and once it detects absence of light, then it's going to turn on the light inside. So let me, like that. I hope you can see. It's not really clear, but yeah, we're just going to use it like that. So I'm going to place my hand on top of the sensor, and we hope that it's going to light inside. So I place my hand just a little bit close, just to, and it's not working. Okay, let me turn back the light and try to see where we might have not connected well. Let me see. Okay, the ground is well, the other pins are connected well. I don't think there's anything which is connected. Maybe this. Then okay, yes, I can see it's okay. The pin that we added initially, it's okay. Yeah, I think the setup is nice. Okay, let me try again and see. I see if it's working or not. Okay, I see the problem. I didn't turn on the power supply. Sorry. Now it's on. Sorry about that. Now let's put our hand on top. Yes, you can see once I put my hand on top, it turns on the light inside of the little house. So yeah, so I put my hand and it turns on the supply. As you can see, the circuit is working correctly. So that's basically how the circuit works. Just a simple light detector system. So this setup can be used in very many applications in homes, with automatic light systems for outside, and even street lights. Sometimes you can see them with a sensor, or some of the street lights turn on automatically when it reaches evening. So this is basically what they do. So thank you very much, guys, for watching. I hope you learned, and next time our home, we are going to continue putting sensors on our home. Next time we are going to put a motion sensor, because we don't want anyone to intrude, or if anyone passes in front of the house, then it's going to detect and turn on an alarm system. So that's what we're going to do next time. So brace yourself, and hope to see you next time. Goodbye.